Here's a video going over the first iteration of the probability exam. I'll give you all the final answers in decimals, but to be fair, a simplified fraction would get full credit as well. An unsimplified fraction loses 1 point on any question. So let's get started. You take the letters from the word bookkeeper and put them all into a bag. For questions 1 through 2, you take out one letter at random. Find the following probabilities. So the probability of getting an O. That's too big of a pen. There we go. Okay, so there are 2 O's out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 O's out of 10 letters total. So the probability of getting an O is 2 O's out of 10 total. And 2 divided by 10 is 0.2. That's the probability. Probability of getting an E. There are 1, 2, 3 E's. So there are 3 E's out of 10 total. And 3 divided by 10 is 0.3. Each question stands on its own, so I didn't take out the O and then move on to number 2, right? I start off with the full word every time. For questions 3 through 4, you take out multiple letters, note their value, and replace them. So I'm putting them back after I take one out. So for question 3, the probability of B, then K. B and then K. So we take out multiple letters, multiple trials. That means we will be using multiplication. So the probability of getting a B and then a K. So to get a B, there is 1 B out of 10 letters total, 1 out of 10 for the B, times K. Now K, there are 2 K's out of 10 total because I replaced the first one. Now, when I multiply those together, I get 2 over 100. 2 over 100 is 0.02. Okay, question 4, the probability of getting an O. So for O's, what's the probability of getting an O? That's 1, 2, 2 O's out of 10. And then the K, there are 2 K's out of 10. And then an E. 3 E's out of 10. When I multiply those together, I get 12 over 1,000. And that's going to give me 0.012. But the question says, or the instructions on the top of the test say to round everything to 2 decimal places. So I'm going to cut that off at the 0.01. So it's important to follow directions. Now you take out 3 letters without replacing them, and they spell K-E-K. What is the probability that this occurs? So we are not replacing them, without replacing them. So once I take the K out, the K is gone. So let's look at the letters. I'm going to move my calculator out of the way for a second, so it's not in the way. Alright, so I need a K, then an E, and then a K. The probability of getting the first K, there are 2 K's out of 10 total. And then we go to the E. But we're not replacing it. So one of these K's is gone. Okay, bye-bye to this K. I've taken that out. E. Now how many E's are there? 1, 2, 3 E's. So there are 3 E's out of 1, 2, 3, 4, 5, 6, 7, 8, 9 letters total. So 3 out of 9. Now I've taken out one of the E's. So I'll get rid of one of the E's because it was taken out of the bag and not replaced. So times Now the last k. How many k's are there now? There's 1k out of how many total? 1, 2, 3, 4, 5, 6, 7, 8. So there is 1 out of 8. Now when I multiply these together, I'm going to get 2 times 3 times 1 is 6 over 10 times 72 is 720. If I had a TI-83 or 84, I could just plug these in as their whole selves, but it doesn't really matter. So let me clear that. 6 divided by 720 is equal to 0.008. But I have to round to the second decimal place, so I got to cut off the 8. It becomes 0.001. Oh, 0.01. Moving on. There are 213 students at Second Chances Middle School. 61 students play football and 81 play soccer, while 31 play both football and soccer. So I have to, first off, construct a Venn diagram. So it's one circle for football, one circle for soccer, and then a box around the whole thing. When I'm filling this out, I'm going to want to label it. So this right here would be football, and this over here will be soccer. And I want to start in the middle. 31 people play both football and soccer. So it's 31 here. Now if 81 play soccer, and there's already 31 here, 81 minus 31 equals 50. Now this adds up to 81 soccer players. So I'm good. I know I'm correct. 61 students play football. So 61 students play football, but there are 31 of them already here. 61 minus 31 is 30. And now what do I do with the 213? The 213 is what this is all supposed to add up to. So if I add these together, 30 plus 31 plus 50 equals 111. But I'm supposed to have 213, so let's see how many we have left. 102. So there are 102 people that are not in either sport. Now how many students play soccer only? These. So 50. How many students don't play either sport? 102. What is the probability of soccer or football? So we'll use the assembly analogy. If the principal said at an assembly, would everybody who played soccer or football this year come up on stage? They would move, they would get up out of their seats and come up on stage, and so would they. So 30 plus 31 plus 50 is 111 out of the grand total, always the grand total. So out of 213. 111 out of 213 equals 0.52. Let's move on. An example of independent trials, an example of two groups that are mutually exclusive. So independent trials means one thing does not affect the other. So one trial does not affect the probability of the next. So things that have nothing to do with each other, we can do like coin flips. So if I flip a coin and get heads, it doesn't change the probability of getting heads on the next flip. We can do dice rolling, or anything else creative that you can come up with. What is an example of two groups that are mutually exclusive? Let's say passing and failing test grades. That's a good example. The idea of mutually exclusive is that if you made a Venn diagram, you would have 0 in the middle. There's no way for you to do both at the same time. There's no way for you to take one test and pass and fail at the same time. Moving on. Provided Venn diagram. Find the following probabilities based on the provided Venn diagram of historical figures mentioned in a new Dan Brown novel. So this is all historical figures. So how many historical figures are there? There's 22 plus 9 plus 11 plus 56. If I add all those together, I get 98. Now what's the probability of me picking somebody and them being an artist? Well, there are 22 and 9. These are both artists. So if I add those up, I'm going to get 31 out of 98. And that's going to equal 0.32. The probability of somebody being an inventor and an artist. That symbol means and. So inventor and artist, well, it's only these people. They're inventors and they're artists. So 9 out of 98, which equals 0.09. Probability of not an artist. Now, who is not an artist? Well, these guys are artists, so forget about them. These guys are not artists. 11 and 56. Add those, gets me 67 out of 98. That equals 0.68. Move this calculator around a little bit so it's not always in the way. Probability of an artist and not an inventor. That's what these symbols mean, and not. So artist and not inventor. So they're an artist. I should make the pen a little bit bigger for that. Okay. So they are an artist, meaning they're in this circle, and they are not an inventor. Non-inventor, and they have to be an artist. So 22. Out of 98, which is 0.22. Artist or not an inventor. So the ors mess people up. So let me be clear about 17. Artist or not inventor. So if you're an artist, you get a check. If you're not an inventor, you get a check. You only need one check to go through. So are the artists over here being included? Well, they are artists. Are they not inventors? Yes. So they're good. They're coming through. They're going to be invited to the fraction down here. Now these, the 9 in the middle, they're artists, they're inventors. So they're artists, they're not inventors. But they got their check mark. They only needed one because it's an or. So they go on through. These guys over here, they're inventors, not artists. So they're artists? No. Are they not inventors? No. So they are not coming. They are not being included in the fraction. Last group on the outside. These guys are not artists and they're not inventors. They don't do either. They are not creative people. So those 56 over here, are they artists? No. Are they not inventors? Yes. So because they are not inventors, they get to be invited as well. So 22 plus 9 plus 56 is 87 out of 98, which is 0.89. Move the calculator over a little so I can do the last two. Alright. Artist or inventor. Let me switch my color again. I like purple. So this is artists or inventors. So if you're an artist or an inventor, you get to come. So they're artists, they're both, and they're inventors. So they all get to be invited. 22 plus 11 plus 9 is going to be 42 out of 98. 42 out of 98 equals 0.43. And lastly, artist given inventor. So that line, if you've forgotten, is a given. So we're given that the person that we're talking about is an inventor. We're given that. So we are only interested in inventors. I actually want to make that line even bigger. So I'm only interested in inventors. Everybody else doesn't matter now because we were given that the person is an inventor. They're not artists. They're not these outside people. They are only the inventors. And actually, I shouldn't have covered up the title over here. But we don't care about these people, so I'm going to cross them all out so I don't get distracted. Now, how many total are there? If I'm looking at the total here, 9 and 11 is 20. So it's going to be out of 20. A given always defines your sample space. How many inventors were there? 20 inventors. 20 in this circle. Now, how many of them are artists? 9 of them are artists. So 9 out of 20 is my fraction, which is 0.45. Okay, well, let's keep going. New section. I didn't mean to close that. We're talking about two-way table now. Find the following probabilities based on the provided two-way table of movie preferences. So that's what we're talking about now, movie preferences. Now, the probability of somebody being male, if I picked somebody at random, that's what question number 19 is asking. What is the probability that if I picked someone at random, they would be male? No, it's not going to fit. Okay. So, a probability of being male. How many males are there? 94. Out of how many? 160. So, 94 out of 160 is 0.59. Probability of being female, number 20. How many females are there? Total number of females is 66. Out of how many? 160. And that's 0.41. The probability of someone preferring dramas. So how many people prefer dramas? 78. Out of how many? 160 total. And 78 out of 160 is 0.49. I think it's time for a color change. The probability of drama given female. So remember what a given does. A given tells me to ignore all the other data. So if I'm given that the person is female, that means I'm not interested in any of the other rows. So let's cross these out. None of these other numbers matter to me because I was given that this person is female. Okay, so now how many is my total? My total is 66. And how many of them prefer drama? 37. You can just use your hands to cover these up, by the way, if you would prefer. 37 out of 66 is 0.56. Okay, 23. Okay, we're back recording. Sorry, I wanted to just edit out the siren, or as much of it as I could. So 23, the probability of drama and male. So remember, this is and. So the probability of somebody being a fan of drama and being male. So here's the drama people, here's the males, and these are the people who are both. 41 out of 160. And 41 divided by 160 is 0.26. And last but not least, question 24, female or action. So what we're doing for female or action, because these are overlapping categories, we are including people, right? We have 4 different groups. We have the males who prefer drama. We have the females who prefer drama. We have the males who prefer action, and the females who prefer action. For this, I'm not really looking at the totals because those are just adding up these numbers anyway, so I'm going to leave these alone. Let's ignore these. Okay? Now, you are invited to this fraction, this fraction party we're about to create over here, if you are female or if you prefer action movies. So these people here, they are not female and they do not prefer action movies. So they are not invited. These 37, they are female. They do not prefer action movies. But because it's an or, we only need 1 check mark. So they are absolutely coming along for the fraction. These 53, they are not female, but they do prefer action. So they are coming along. And lastly, these 29, they are female, and they prefer action. It's double good, so they will be invited. So I'm going to add these up. 37 plus 53 plus 29 is 119 out of the total, which is 160. So 119 out of 160 is 0.74. Now I know what some of you would want to do. So let me just address this. Female or action. You probably want to take the probability of being female plus the probability of preferring action. And you're on the right track. Just requires a small modification. The probability of being female is 66 out of 160. Now how do we get that 66? Well, we did 37 plus 29 equals 66. I'm going to color code this to make this as easy as I can. Action is going to become dark green. So now action. Action is 82. Oh, my color switch didn't stay. So action is 82 out of 160. But how did I get that 82? I did 53 plus 29 equals, I guess it should be on this side, 53 plus 29 equals 82. So you see the problem here. I've used the 29 twice. I used it once to get the blue total, and I used it once to get the green total. So that 29 has been included twice. I double counted them. If I take these numbers and I add them up, I'm going to get 66 plus 82 is 148 over 160. Now that's almost everybody. That's almost 100%. And look at the difference here. We got 119, you got 148. 148 minus 119, we got a difference of 29. Of course we did, because we would actually have to subtract off the intersection, because we've double counted it already, minus 29 over 160. And that would get me 119 over 160, which is the correct answer, which is this decimal. Okay, if that just made it more confusing for you, back up, watch the answer to 24 again, and then just skip ahead, cover your ears, and say la 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 for the whole time that I'm explaining that. But let's move on to question 25. The probability that Jada studies and passes a math exam is 0.8, and the probability she studies is 0.52. What is the probability that she passes given that she studies? Well, there's only one formula to use for questions like these, and it is the dependent formula. The dependent formula for ands. So she studies and passes. So let's see. The probability of A and B is equal to probability of A times the probability of B given A. Now this is when things are not independent. But let's see. What is the probability that she passes given that she studies? So it seems like we are talking about a B given A scenario. So I'm going to move this formula over, cut off a little bit of what I've been writing here, just so I can clean it up, make it look a little nicer. So let's take this formula. Formula's going here. So the problem is, we're talking about passing and studying, and I don't know which one to make A and which one to make B. So let me put it this way. B given A. So passes given studies. So it looks like passing is going to be B and studying is going to be A. So when we talk about her studying and passing, studying is A and passing is 0.8. The probability that she studies, which was A, is 0.52. So the probability of A equals 0.52. Forgot the P. Okay, so I know two pieces to this. Probability of A, and I know the probability of A and B. Now what do they want me to find? What is the probability that she passes given that she studies? So what is the probability of B given A? So they just want me to find what this is equal to. That's cake. So the probability of A and B is 0.8. The probability of A is 0.52 times the probability of B given A. In order to get the probability of B given A by itself, I'm going to want to divide off the 0.52, cross those out, and I get the probability of B given A is equal to this. Well, 0.8 divided by 0.52 equals 1.54. Now, it's not super important because you weren't asked to interpret the context of the question. This is the numerical answer, but it doesn't actually make sense as a probability because probabilities are supposed to be between 0 and 1. If you acknowledged this and you said that this is impossible or that the scenario didn't make any sense, I would have given you full credit. But as is, I just wanted you to prove to me the algebra, so 1.54 was the correct answer. Moving on, another two-way table. I'll go a little faster on this one because I think that we get the point by now. We've done a few of these. The probability of practicing. Practicing is 0.4 out of 1, which is just 0.4. The probability of losing, so there are 0.3 out of 0.1, which is just 0.3. The probability of losing and practicing, well, here's the losers, and here's the practicers, so it's 0.12 out of 1, which is just 0.12. Probability of losing and not practicing, so here's the losers, here's the not practicers, so it's 0.18 out of 1, which is 0.18. I just realized I'm going out of order, so I'm going to go over to 29, resume some order. 29, the probability of not practicing and winning. So not practicing and winning. That's 0.42 out of 1, which is 0.42. The probability of practicing or winning. So remember, this is a one check mark scenario, an or, right? So who gets to be included? Not looking at the totals. Keep them out of mind for now. So practicers are invited, right? So here are the practicers. You get to come because you practice. You get to come because you practice. And the winners. So they get to come as well, because though they did not practice, they did win. And if you want a little bit of proof here, 0.18. 0.18 is the people who lost, so they did not win, and they didn't practice. So they didn't practice. These 18 over here will absolutely not be invited. So when I take those numbers, and I do 0.28 plus 0.12 plus 0.42, I get 0.82. It'd be over 1, but we don't actually need that because 0.82 over 1 is just 0.82. 0.82 over 1, same thing. Okay, zoom out. Back to business. Question 32. Practicing given not winning. So remember, this is given not. So given that they didn't win, that means that we are covering up all the other data. So given that they didn't win, so we're crossing out winning and we're crossing out the total, because given that they didn't win means they lost. Right? Given not winning. So only losers we're looking at. Now, so what's my total? My total is 0.3. That pen is way too big for that purpose. Okay, so my total is 0.3. So it's going to be out of 0.3. Now how many of them practice? 0.12. And if I pop up my calculator, 0.12 divided by 0.3, I get 0.4. The probability of winning given practicing. So given practicing means we're only looking at practicers. So we are not looking at the people that didn't practice. We are not looking at the total. We're only looking at practicers. So let's see. Total number of people who didn't practice is 0.4. It's out of 0.4. And how many of them won? 0.28. So 0.28 out of 0.4. And 0.28 out of that's all right, 0.4 is 0.7. Now, last one about this Venn diagram. What is the probability of winning given losing? This is just showing me that you understand the concept of a given. So if you are given that you lost, then you cannot have won. The probability equals 0. Well, I guess the probability of win given lose equals 0. Because if you're given that you lost, you cannot have won. They're mutually exclusive. There's no way for you to win and lose, right? If it's just one game, could you win and lose the same game? Is there any way for one game to fall in here? No way. So are winning and practicing independent? Justify that mathematically. So the rule that everybody liked as far as winning and practicing was this rule. Probability of A and B is equal to the probability of A times the probability of B. So let's call winning A and let's call practicing B. So the probability of winning and practicing, that's A and B. Winning and practicing is 0.28 out of 1. So that's going to be 0.28 is equal to the probability of A, which is the probability of winning. Let's see, what's the probability of winning? The winning is 0.7 out of 1, which is just 0.7. So the probability of A is 0.7 times the probability of B, which is practicing. So what's the probability of practicing? Let's see, who practiced? 0.4 people practiced out of 1, which is just 0.4. So 0.4. And when you multiply on the right-hand side, let's prove it to you. .7 times 0.4 equals 0.28. So we get 0.28 on the right is equal to 0.28. Now because they are equal, that means they are independent. Now independent means that two things do not affect each other. So what does this mean about Saturday practice attendance for Garrett? It means that Garrett doesn't need to go to practice because it won't change the probability of him winning. And that's the gist of it. So that was the whole test. If you want to retake, it'll be later this week. So good luck. Study up.